Welcome. Let's start this lesson with a quick warm-up. Pick one of the two equations and solve it by completing the square. Pause me and then come back when you're done. Here are the solutions. I've also written them in two different ways. The solution here, I've written them as two separate values, 3 minus the square root of 7 and 3 plus the square root of 7. For this one, I've written it in a more compact form, -2 plus or minus square root of 10 over 2. Either way is fine. I'm going to work now number 2 together. If you feel good to go on this one, then just skip ahead in the video until we get to the next section. When I solve by completing the square, the first thing I know is I need a to be 1. So I'm going to divide both sides of this equation by 2. And I'll distribute the division to get x squared plus 4x plus 3 halves. I love fractions, they're absolutely fine, is equal to 0. Next, I want to isolate my variable terms on just one side of the equation. So I'll subtract 3 halves from both sides. 0 minus 3 halves is -3 halves. I'm now going to get ready to complete the square. X squared plus 4x. I'm going to add a number that will make that a perfect square trinomial. And I want to remind myself that whatever I add to one side, I also have to add to the other side. All right, so I'm going to take my b term, 4, my coefficient b, divide that by 2, which is going to be 2, and then I'm going to take 2 and square it. So 4 completes the square. And I can now factor that perfect square trinomial into x plus 2 squared. And on this side, 4 is the same as 8 halves. So -3 halves plus 8 halves is 5 halves. So now really I've finished the process of completing the square, and I can now use the square root method. I've isolated my variable. It's in a binomial being squared, so I'll take the square root of both sides. And I want both the positive and the negative square root, 5 halves. And then I'm going to subtract 2 from both sides. So it's the same as adding -2 to both sides. And at this point now, my last step is to simplify this radical. As a reminder, we're going to distribute the radical, so square root of 5 over the square root of 2. And then no radicals in the denominator, so I'm going to multiply numerator in the denominator by square root of 2. And that's going to give me x is equal to -2 plus or minus the square root of 10 over 2. So here, this section, completing the square, a little algebra, and then finally simplifying a radical. All right, we're done with the warm-up. Let's move on to the lesson. In this lesson, you're going to learn how to solve quadratic equations using the quadratic formula. We'll start the lesson by exploring how the quadratic formula connects to the other techniques you already know how to use. So we'll start with the square root method. The square root method is really just using basic equation solving strategies to isolate the variable. The problem with the square root method is that it can only solve specific types of equations, such as, here's an example, x minus 3 squared is equal to 7. We're completing the square. Completing the square converts any quadratic equation into an equivalent equation that can be solved using the square root method. So we could take this example equation, complete the square, and it would just bring us back to an equation that we can solve with the square root method. Now, I've got to be honest with you, mathematicians, we love completing the square. It's strangely satisfying. But we also love to be efficient and to generalize. So one day, a mathematician took a generalized version of the quadratic equation. We've seen this before, ax squared plus bx plus c equals 0, and solved for x by completing the square. The general solutions she found were x is equal to the opposite of b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And This is the quadratic formula. Now, when you see the quadratic formula, it's actually often written with these two fractions, excuse me, added together. So you might see it as negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I wonder, are you curious about how that mathematician actually went from ax squared plus bx plus c and the steps she took to get down here? If you are, there are a couple options for you in the playlist once you've had a chance to practice, and you might want to explore those. All right, so now the quadratic formula, because it's just completing the square and then using the generalized form, we can use it to solve any quadratic equation. All right, so let's try a few. We'll start by solving this quadratic equation, 2x squared plus 8x plus 3 is equal to 0 using the quadratic formula. Now watch out. We can only use the quadratic formula if one side of the equation is equal to 0, which it is in this case. All right, my first step is I need to know a, b, and c, and I can just decode them from the equation. A is equal to 2, b is equal to 8, and c is equal to 3. So I can use my quadratic formula. X is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So using the quadratic formula is really a matter of knowing what a, b, and c are, substituting them into the formula, and then doing some arithmetic. All right, so let's substitute. B is 8, so negative 8 plus or minus the square root of 8 squared minus 4 times 2a times 3c all over 2 times 2a. All right, so we've substituted our values. Let's just go ahead and do the arithmetic. All right, negative 8, and then I'm going to take 8 squared is 64. 4 times 2 times 3 is 12 times 2 minus 24 all over 4. And let's finally do that subtraction in the radical. All over 4. Okay, so at this point, we have our arithmetic done, and it's just a matter of simplifying. So let's simplify from this point. Let's see, the first thing I'm going to simplify is my radical. 40 has the perfect square factor of 4, and the square root of 4 is 2. So this is going to equal to negative 8 plus or minus 2 times the square root of 10 all over 4. Next, I'm going to go ahead and distribute my division. So I have negative 8 divided by 4 plus or minus 2 square root of 10 divided by 4. Negative 8 divided by 4 is simply 2, negative 2, plus or minus, and I can divide out that common factor of 2 to get the square root of 10 over 2. So I can either write my two solutions like this, or I can say x is equal to negative 2 minus the square root of 10 over 2, or x is equal to negative 2 plus the square root of 10 over 2. So that's really mathematician's choice, which way you like it. Let's interpret what this means a little bit. I think a number line picture can be helpful. All right, here's 0, 1, 2, 3, 4, negative 5, that way. All right, I'm going to start at negative 2. And then let's see, if I add the square root of 10 over 2, okay, square root of 10 is a little bit more than 9, so square root of 10 over 2 is a little bit more than 3 halves. So I can either add 3 halves, here's one of the solutions, or I can subtract about 3 halves, and there's the other solution. So this is a nice way to see a little bit of symmetry that we're starting at negative 2 and adding or subtracting this number that's about 3 halves. All right, let's end with 2 more problems. And what I recommend you doing is pausing me and try to solve both using the quadratic formula. and then come back and I'll show you the solutions, and then we'll also work both together. So go ahead, pause me, give it a go, and then come back. All right, here are the solutions to the two equations. We're now going to work each of them in turn. If at any point you feel good to go, you're done. Leave the video and go ahead and do some practice on your own. All right, let's first look at our first equation. I'm going to use the quadratic formula. Let me just decode. I know that A is equal to 3, B is equal to 10, and C is equal to -8. Watch those signs. All right, what is the quadratic formula? X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Let's substitute our values for a, b, and c. -10 plus or minus the square root 10 squared minus 4 times 3 times -8 all over 2 times 3. Okay, we're substituted. Let's just do our arithmetic. -10 plus or minus 100. All right, so that's going to be a negative minus a negative, so plus 96 all over 6. X is equal to -10 plus or minus the square root of 196 all over 6. Okay, so we've now done the arithmetic. Our next step is how can we simplify this? And I don't know if your brain is lighting up the way mine is, but I know the square root of 196 is 14. So we have -10 plus or minus 14 all over 6. Let's first take the subtraction case. -10 minus 14 divided by 6 is equal to -24 divided by 6, which is equal to, let's not forget our x's, -4. All right, so that's where our -4 came from. Or let's use the addition. X is equal to -10 plus 14 divided by 6. So x is equal to 4 divided by 6, and that fraction simplifies to 2/3. And there's where we got the second solution. All right, so think for a minute. Were you able to solve that one? Where did you get stuck? Can you think about what your error is and what you would do differently? All right, let's look at the second problem. All right, so this was a little bit of an interesting one. Let's just go through that same process. Let's first decode. We have A is equal to 4, B is equal to 3, and C, oh, before I do anything, I have to have one side set equal to 0. Did you remember to do that one? So x squared plus 3x, I'm going to add 2 to both sides. Because again, remember that watch out, one side has to equal 0. All right, so C now is going to be +2. All right, let's use the quadratic formula. X is equal to -b plus or minus the square root b squared minus 4ac. Hey, is this starting to feel a little familiar yet? Okay, at some point you're going to have it so memorized. All right, let's substitute the values we know. -3 plus or minus the square root of 3 squared minus 4 times 2 all over 2 times 4. Okay, I always like substituting it in. It's a great way to catch errors later on. So now let's do our arithmetic. -3 plus or minus the square root of 9 minus 1632 all over 8. And let's do that subtraction. Inside the radical, -2/3 all over 8. Okay, do you see the problem? I guess it's not really a problem, but square roots of negative numbers. A square root of negative number is not a real number. Think about a simple example, square root of -9. There's no number that you can multiply by itself to get -9. 3 times 3 is +9. -3 times 3 is +9. So here we say square root of a negative number, it's not a real number. To let you know it is a number, it's just an imaginary number, but it's not a real number. And when we're solving quadratic equations, when we're solving equations, we're looking for real number solutions. So that's why we got up here and we said, hey, We were cruising along on our quadratic formula, but we hit a point where we were trying to take the square root of a negative number. No real number, so there's no real solution. All right, so I hope this lesson has got you started on using the quadratic formula to solve a quadratic equation. One nice thing about the quadratic formula, again, just like completing the square, you can use it to solve any quadratic equation. And it's really just arithmetic and simplifying. All right, go practice, and please let me know if you have any follow-up questions.